So today I hope you experience a real sense of deja vu. Today's examples are going to be a lot like yesterday's examples. Really the only difference is instead of dealing with a common difference, we're going to be looking at a common ratio. So in 9.3 we're going to talk about geometric sequences. With geometric sequences, you have a sequence that involves a common ratio. And that common ratio is usually, or I should say always, denoted R. The variable we use for the common ratio is R. A geometric sequence is found by taking a sub n equal to a sub 1 times r to the n minus 1 for all values of n greater than or equal to 1. Yesterday, how I talked about the n minus 1 kind of accounts for the fact that we've already used the first term right here. Same deal. We go r to the n minus 1 to kind of back us up a term, or to say we've already included the first term. So let's take a look at example A. We're going to write a formula for the sequence 3, 6, 12, 24, 48, and then so on and so forth. How do you get from 3 to 6? Well, you multiply by 2. How do you get from 6 to 12? Again, multiply by 2. How do you get from 12 to 24? You got it. So there's your common ratio. So we can write a formula. A sub n is equal to that first term times that common ratio, not 6. The common ratio is 2, and we raise that to the n minus 1 power. Now this is an explicit formula. This is an explicit formula. Like we did yesterday, we can also write the recursive formula. The recursive formula takes into account that we know the term right before it. The recursive formula for a sub n will be a sub n minus 1, and then times, not 3, but times 2, times that common ratio. So to find, let's say this is the first, second, third, fourth. If we wanted to find a sub 5, we would have to know a sub 4, and then we would multiply it by 2. Well, sure enough, a sub 4 is 24, and 24 times 2 gives us 48. Yep, a sub 5 is equal to 48. So a recursive formula is just taking the term, the previous term, and multiplying by 2. We wrote that in our notes yesterday, that this is that previous term times the common ratio. All right, in example B, let's find the 10th term of the sequence 4, 12, 36. So not always will the common ratio be so obvious. If it's not obvious what the common ratio is, you take the second term divided by the first term. You take the third term divided by the second term, and then you could take the next term and divide it by 36. And hopefully, all of these ratios would be the same. Like 12 over 4 is 3, 36 over 12 is 3, 72 divided by 36 is going to be 3. No, that's not right. What's 36 times 3? 36 times 3 would be 108 maybe? I don't know. Okay, so anyway, common ratio is 3. So to find the 10th term, I want to know a sub 10. I know that my first term is 4, my common ratio is 3, and then to the n minus 1. So in other words, to the 10 minus 1, or 9. So 4 times 3 to the 9th power. I have my calculator on standby. This was the calculation I did yesterday. 4 times 3, raise it to, see what button I push to get up to the exponent world, and that gives me 78,732. And that's how I would find a sub 10. Letter C, these are the good problems where we have to find the missing term. I think this is fun. So what do we know for sure? We know that this is a sub 1. We are missing a sub 2, a sub 3, but we do know a sub 4. We also know that it's a geometric sequence. With a geometric sequence, a sub n is equal to a sub 1 times r to the n minus 1. I think I'm kind of rushing through this. Do you need to pause and catch up? Okay, here we go. So that's how we find a geometric sequence. Something else we know is that a sub 1 is 2. Oh, we do not know what that common ratio is. Well, what can we do from here? We know that a sub 4 is equal to negative 54. So I can say that negative 54, I'm kind of plugging this into that formula. Negative 54 is equal to a sub 1 times, I don't know what that common ratio is, to the 4 minus 1. N, remember, is going to be 4. So I'm looking at negative 54. Negative 54 is equal to 2 times something. I'm going to use the r because that's the appropriate variable that goes there. R to the third power. Divide by 2. Divide by 2. Negative 27 is equal to r to the third power. Well, what's going to undo that third power would be a third root. Third root on both sides gives me r is equal to negative 3. Remember, we can take an odd root of a negative number. So if r is negative 3, will that fit the bill? Will that get me from 2 to negative 54 in 3 bounces or whatever? I have 2. 2 times negative 3 would give me negative 6. Times negative 3 would give me 18. Times negative 3 would give me, negative 54. Very good. I did it. I found my missing 2 numbers by using the formula for a geometric sequence to find r and then filling in my sequence. Isn't that fun? Yes, it is fun. All right, last little thing for us today, a geometric mean. Yesterday we talked for a brief second about an arithmetic mean or an arithmetic mean. The geometric mean is just the number in the middle of 2 terms. Of 2 terms in a geometric sequence. I'm going to abbreviate geo sequence. And the formula for the geometric mean is the square root of x times y. All right, write that down for future reference. And that's a wrap for today.